Welcome everyone to the virtual breakfast series put out by Michigan State University's field crop team. I hope everybody's having a good morning. We've been talking here for a few minutes between the different speakers, and we realized it's a big state. We've got the south end of the state thinking about breaking out the irrigation, and the center and the upper part begging to turn off the water. So we go from one extreme to the other. Today, I'm here to help just host this discussion with our speaker, our irrigation specialist, Younsuk Dong. We'll be talking about those things and the weather, and then maybe a few minutes to answer your questions that pop up. So, and here's the big job I get. I get to introduce a fine young gentleman that's been working at MSU for quite a while, but he's in a role here at Michigan State University working out of agricultural bio and just, I'm sorry, work for two universities, so I get the names screwed up. Biosystems Ag Engineering at Michigan State University. Dr. Younsuk Dong is a professor working in improving irrigation management skills. And he's going to be talking to us today about strategies for efficient irrigation water management.
All right. Well, thank you, Lyndon. Good morning. Today I'm going to talk about the strategies to improve irrigation water use efficiency. The one thing that we can do to improve water use efficiency is checking irrigation system uniformity. This might be really good time before the crops too tall or growing. Might be good to check the uniformity of your irrigation system. So the poor water distribution of your irrigation system can result in over or under irrigated area. So if the area gets underwater, which can reduce the crop yield and grain quality, if the area gets overwater, which can cause runoff and leaching water nutrient below the root zone. So it's important to check whether your system is applying water the uniform across the field. So how do we check the uniformity? So as you can see on the figure, there's a little white cups are placing about 10 feet from the center to all the way up. This we call it catch cans. Catch can usually placed at about 3 feet high from the ground with the 10 feet spacing. So once we place these catch cans, you run a pivots over and we collect the volume of each cups, see how the uniform of your irrigation system is. A couple things to consider is are the precision of uniformity testing decrease when wind exceeds 2.2 miles per hour. And if wind speed goes beyond 11 miles per hour, the test may not be valid. So we need to have really calm wind condition to do this testing. Once you collect all the volumes from the cup, you can enter the data into this tool, which is available from MSU Irrigation Extension website. So you can download it and use it. Once you enter all the catch can volumes in this tool, it will give you the system uniformity coefficient. So if this coefficient is greater than 85%, the irrigation system is not likely need a major adjustment to the sprinkler package. If it's less than 85%, we need further analysis of a sprinkler package, and maybe we gotta take a look at the individual section where it's putting more water or underwater. So may require changing the sprinkler packages. I'd like to share one example, the case study we done last year. This is about 1,500 feet center pivot systems, and the sprinkler package are over 10 years old. And the bottom graph shows y-axis the volume of water, and x-axis are the distance from the center. And each dot on the graph is the cup locations, catch can locations. So as you can see, the top graph before they're having all the sprinkler, which puts pretty ununiform application across field. So the uniformity coefficient we got from using the tool was the 75, which is less than 85. And after the bottom graph shows after we replace the sprinkler package, as you can see now, it's much uniform. The coefficient of uniformity came out 94. So this pivots, the material costs for replacing sprinkler package were $4,300, and labor costs for replacing sprinkler package were $2,200. And so the total cost, total investment was $6,500 to do this. Once we have that data, because now system is more efficient, we can estimate how much energy saving could be occur because of efficient water use, which came out $1,600. So the payback period of this updating the sprinkler system is approximately 40 years. So considering manufacturers' typical recommendations to replace sprinkler package are 7 to 10 years, I think this is worth investment. Another strategy we can do is using irrigation scheduling tools. In general, there are two different tools. One is the weather-based irrigation scheduling, which utilize the reference evapotranspiration and the crop coefficient. Another type of irrigation scheduling method is called soil moisture sensor-based irrigation scheduling, which basically using the soil moisture sensors to estimate the moisture content of soil, and use the information we can determine how much to water and when to water. So first, I'm gonna jump on the weather-based irrigation scheduling. So as you can see on the equations, the ETC is crop evapotranspiration equals RPT times KC. So RPT is reference potential evapotranspiration, and the crop coefficient is KC, which depends on the crop type and the crop specific stages. So that KC is just multiplier values. So looks like we need the RPT. So where do we get that value? The one source is you can go to National Weather Service website, and you can go out to their website. You can select your location to get the ET. Another source is you can go to MSU EnviroWeather website. So MSU EnviroWeather has over 100 weather stations across Michigan. So I'm sure you can find the ones close to your field to get this reference ET. The one of the tool that Lyndon and I use is this sign up for RPT text alert. Once you click it and you can sign up, you can put your phone number or email address and select the station, weather station that you're interested in it. And once you do that, every day between 5 to 6 o'clock a.m., you get the email or the text, which include last 5 days of RPT and next 7 days for forecast RPT. So you can see how each day how much the RPT were last 5 days and next 7 days. So it's pretty handy. I'd like to quickly go over the example of crop, how we calculate the crop ET. So crop evapotranspiration equals RPT times KC. So on the right, the graphs are showing how the crop coefficient changed based on the crop type and their stage. So as you can see, KC changes. So I went to MSU EnviroWeather website. I selected Mendon, which is in Southwest Michigan. I select the area, select the time period from the June 5th to June 11th. And from that period, total ET from that period was 1.36 inches. So that's RPT I have for that period. And corn at B4 stage, the crop coefficient was the 0.2. So once you multiply that RPT times KC, you get the crop ET, which came out 0.27. So although the reference ET for that period was 1.36, actually the corn water use is 0.27. So for the soybean example, I picked up V2 as in this example, and RPT is 1.36, and V2 for crop coefficient for soybean is 0.5. So once you multiply those numbers, you get 0.68 inches. So here's the example you can calculate it to get extra crop ET. We have MSU Irrigation Scheduler program, which is Excel based, and you can go on this, you can download for free from our website, and you can type in the soil information, the crop emergent states, and from there we can calculate crop ET, and has a function to automatically download the weather data from MSU Environmental Weather. So if you don't want to do with hand calculation, you can use this Excel version because that automatically calculates for you. This year we just launched the app-based MSU Irrigation Scheduler. So this is just exact same the calculation, and we're trying to mimic the same platform, that same all the background information that we had at Excel based to this app version. So you can use this QR code. I'd be happy to drop the link in the chat later, but you can use QR code to download it. It's free, and this year this is our first year, so we're looking for to get more comment and suggestion to the app so we can improve it as it goes. So please download it and try. If you have any issues or question, just feel free to email me. Be happy to answer. Another type of irrigation scheduling method is soil moisture sensor based. So there are just a lot of different soil moisture sensors out there, and bottom line is all soil moisture sensors measure the moisture content, right? So we like to put the sensor in multiple depths so that we can keep track on how the water is flowing, and we can also evaluate irrigation practice. So here's an example of the sensor data we collected last year. So after irrigation, how much that water really impact in soil. So we install on this field, we install soil moisture sensors at 6-inch depth, 12-inch depth, and 24-inch depth. So 6-inch depth sensor is the red, and green is 12-inch depth, and the gray is 24-inch depth. So after irrigation, as you can see, all sensors responded. So it means and if the goal is keep only wetting the top 24, and after irrigation, the 24-inch depth sensor responded, which means the water was applied a little more than what it should be. So this is one way we can see whether we are putting too much water or too little water, right? So this is one thing you can do with the sensors. This is data we just collected. Brendan and Abraham just collected from White Pigeon area in Michigan. This is potato field. One thing I think some companies provide is composite soil water data. So basically they composite multiple depth of sensors and make it into the inch. So how much inch of water are available in the root zone. So you can do that, and with this information, you can set the filter capacity, which is based on soil texture. So we need to know what the soil texture of your farm is to get the filter capacity and the wilting point. And you can also set the maximum allowable depletion, which is typically 50%. The soybean, we can go maybe a little down the 60% MAD, maximum allowable depletion. But this is one example. You can use sensor data to see where you are at, whether your moisture is close to the capacity or maybe close to maximum allowable depletion. Maybe that's the time we should, maybe you need to turn the irrigation on. Couple things to consider is if your pivots takes 48 hours, 72 hours to apply 1-inch application, then maybe you want to start trigger the irrigation a little before then it actually hit the maximum allowed depletion, right? Couple things really, just recall the most critical time for corn for irrigation management is from the VT, the Tessel, until the R6. For soybean, is from R3 to R6. So just keep that in mind. I'm very excited to announce the Miss Angie Grades. She's a new irrigation extension educator based on the cold water in Michigan. She's not she's additional extension educator supported by state of Michigan. So she already joined and couple corn soybean and irrigation system uniformity project with Lyndon and I. So if you're around the cold water, if you have any question on irrigation, please feel free to reach out Angie. I put her email address and her office phone number. So please feel free to reach out to her. Lastly, I'd like to mention we have MSU Irrigation Extension website, which we've been putting the extension bulletin couple per year and the articles, and there are other resources can be really beneficial and they relate to irrigation. So please stop by our irrigation website and check find some really useful information for you irrigation. So all right.
No, thank you, Younsuk. I think from there we go into questions, and I believe Jeff is still there. Jeff, we had a weather-related question. What date does the degree day, the growing degree day calculation start from?
The values or the figure that you saw was the beginning of May. But I would note that, of course, depending on the crop, if we look at an overwintering crop like wheat or alfalfa perennial that comes back, we also have degree days that go back to the beginning of March as well. And you can actually on our EnviroWeather site, you can actually specify that. But the ones you saw specifically this morning, they were oriented at corn and assuming a planting date of the 1st of May.
So from there, Dr. Dong, I see there's an irrigation question here. We talked about K sub Cs and where we could get those from. And also, how would we adapt this for drip irrigation?
Yeah, so K-pub-C is available on our website. I can drop the link where you can see the KC values for different crop and their different stages. Yes, the scheduler program can be used on drip as well. A lot of drip irrigation, the tapes they go by gallon per hour. So all you gotta do is conversion. So one conversion that you can use is 0.62 gallons of water make up 1 inch in a square foot. So you can use that conversion factors to convert from your inch application require 0.62. So you can use that for drip application. So
good. So we just convert the amount of acres or the amount of feet that we actually are irrigating by that coefficient of that number to get the gallons. Okay. If there was some questions about just where we got the tools, if you do a Google search for MSU irrigation, you can come up to the website that we house our information. It's sort of a library of tools and past articles and fact sheets. The irrigation uniformity tool that he showed was up there. So that was one of the questions. Let's see. Mr. Monta is looking for when's the research day at Frankenmuth. Somebody's going to have to help me find that. I did get a note that we should highlight. Weed Day is June 26th at campus. So please make sure you have those opportunities coming forward.
Lyndon, the Michigan Wheat Summer Field Day is Tuesday, June 25th at the Saginaw Valley Research Farm beginning at 8:15.
Okay.
And Lyndon, I believe the Severick Field Day, the one in August, is on August 20th.
Great. So everybody get those dates down. Can we repeat those one more time?
June 25th. Sorry, Chris. June 25th for the Wheat Summer Field Day
And then August 20th, I have on my calendar for the main field day at Severick.
Okay. Please put your questions in the chat. And as you may have noticed, we've got a number of our MSU specialists out there to help us with any questions that come up. I think Dr. DeFonso was on talking to us before the meeting. She had some important things to talk about.
Oops, sorry. I'm not sure if they're very important. I was going out to the field today. We have a slug plot that Monica Jean put up in the Saginaw area. So we'll see if any slug products actually work. And what else? Asiatic garden beetle is pupating now for those in the southern part of the state that have that as a pest. Haven't had a lot of calls about that. And other than that, waiting for western bean. If you trap for western bean cutworm, I'd put out your bucket traps a little early. I'm going to put mine out next week. I usually don't start trapping till like first week of July, but we're a little bit ahead. So I'm going to put out, I like to get a 0. So if you're a trapper, you might consider putting it out next week.
Great. And when if there's other specialists out there, please chime in. In the meantime, we got an irrigation question here for Dr. Dong. Talks about, well, it's actually a soil moisture question across the state. What is the soil moisture? And is there a hope that soil water carrying capacity can get us through this dry period?
Jeff, do you have the subsoil data across the state, or?
The graphic that I showed certainly has some of that. I can actually while we're talking here, I can go and get a subsoil. But the good news is at this time of the year, typically we have a high subsoil moisture. So it's just a matter of the roots being deep enough to access that. And actually in many years it's a positive thing, because if it's a little drier at the surface, it does force the roots down. And of course, the more access to water we have later on, especially the better off we are for the crop to deal with it. But we should be, for mid-June, we still should have fairly decent. And let me, if Younsuk, you want to comment, I'll try to find an image for that here.
Yeah, well, some of the sensor we already deploy on the Southwest Michigan does have some moisture. So, but depending on where the roots are, so that's another factor. Where your crop stage at now, how's the impact the moisture? So,
And Younsuk, let me just
yeah,
share a screen here. And what you're looking at here currently, this is an image as of current, but this is looking at moisture really in the lower 2 to 3 feet, or actually 1 to 3 feet. So this is looking at typically below the 1 foot level, down to about 3 feet. And this is relative soil moisture. So that's plant available. It's the difference between the field capacity. Younsuk had a great image of that, and the wilting point. So it's it's the important number for the soil. It's what the soil can provide to the plant and to the roots, the relative amount. And the index that you're looking at here is expressed again in a percentile, or how much percent. And what you see here, again, not surprisingly, I'm sure for some of you, it's green. So it's above normal. It's relatively high in the northern part of the state, and it's relatively low across portions of the south, or lower than normal. But because it's still mid-June, there's certainly water there. It just has to be the roots down deep enough to extract it. We will need, though, of course, like everybody appreciates, we will need water certainly in the upcoming. The peak water use rates are still to come in the season, so we obviously need more water, either with rain or with added irrigation.
Great. Thank you. Dr. Dong, could you expound a little bit about your collaboration with Dr. Shilvers on minimizing soybean diseases under irrigation?
yeah.
Sort of the general recommendations.
Is Barley here today? But if you do, please feel free to chime in. But overall general recommendation is we suggest to water when it's needed. And in presentation, we we suggest to water only water from the R3 to R6. Those are the critical time. I probably suggest avoid the flowering time, irrigating during the flowering. So if you're watering R3 to R6 stages, I think that's probably you can maximize water efficiency while minimizing disease. So that would be our recommendation at this point. But we continue to explore how does irrigation contribute. Oh, there's Marty. Yep.
Hey, Younsuk, yeah, I think
Yep,
that's
yep.
a good summary of what
Yep.
we're trying to do. Yeah, I think just in general too, I mean, I think some of the other experiments you've been looking at on farm water use efficiency and maybe how that can relate to disease. We certainly want to, I think, certainly listen to Younsuk and Lyndon and the other water irrigation extension specialists, because it's really important to understand our system so that we're not overwatering the canopy, getting the canopy wet too often. We've seen that in the past, blow up tar spot disease as an example. And of course, if we're over irrigating too, that can promote white mold, especially prior to flowering. So I think that's a couple of good takeaway points. And we have some work at the moment, right, looking at day versus night irrigation. We're going to factor in some foliar disease in the soybean as well, see how that plays out.
So, Dr. Chilvers, while you're there, we ought to cover other diseases, but the one thing I didn't hear you and Younsuk mention was keeping your applications fairly large so that you're doing fewer large applications rather than many small applications. So you're not wetting the crop as often. Do you agree?
Absolutely. Anything we can do to minimize the wetting events will help minimize some of those foliar disease development. Yeah, I think that's really a critical point there. And we've seen that in the past, with tar spot, where people have been running an irrigation unit like twice per week versus once per week. And that was enough to really drive, very large differences in disease development. So
Right.
important to pay attention to what you guys are saying with respect to calibration and water application techniques.
Good. Anything else to say on diseases outlooks?
Well, sure. Yeah, just really quick. So tar spot has been found in Kentucky, not Kentucky, sorry, Kansas, northern Indiana, which would be most relevant to us. I think the message from all the pathologists across the country is don't freak out. Like, we've got a long way to go. So if we can afford one fungicide application this year, we'd really want to push that to closer to the tassel timing and potentially later, depending on how the season plays out. And we've got a long way to go. So I think there'll be a little bit of buzz around some of those tar spot findings. And I have no doubt that if we really go and look, we might be able to find tar spot here in Michigan. Just let us know, I guess, what you're seeing out and around the state as well. But we've got a long way to go yet, so I wouldn't freak out just yet. Just keep an eye on things. Start scouting.
Great. Thank you. Question here about alfalfa and the K sub C. And Younsuk, do you want to say something about where to find a K sub C, and in general how alfalfa has all the cuttings make a difference in the K sub C?
Yeah, I did drop the link in the chat. I can do one more time where you can find the crop coefficients for alfalfa. So you can go on the website to get the alpha K sub C. Yeah.
In general, the alfalfa has a curve going from low up to about 100%. So it uses about the same as grass about the time you're going to cut it the first time. And then from there on in, you redo that growth curve each time the cutting, starting fairly low with the K sub C, and then to a little bit more than grass right before you cut it. So it has, if you have 3 cuttings, you have 3 curves over the year that you would follow. And we can get you some details on that. We got an insect question coming in. I hope Dr. DeFonso sees that. There's a question here. Is it economical to build soil moisture with irrigation early, or early irrigation to build soil moisture? Younsuk?
Oh, sorry. Could you say what that?
Is it economical to build subsoil moisture with early irrigation?
I think it is the beneficial for the because we see over the time, especially maybe late June and July, if you don't have a good starting, it's hard to keep it up with the moisture. So I would suggest to have good soil moisture in the subsoil. Yeah.
How about those people? I see some corn that was just planted here on rye that was taken for forage, or other cereal crops that were taken for forage, and then corn planted into them that first week of June. It's sort of a different situation, right?
Yeah, yeah. So the one I guess easy way to do is, maybe if you have portable soil moisture sensor, see where the moisture is at. That will probably tell you where what the moisture content at different depth. If rye used up water, and if you don't have good starting, then yeah, probably suggest to water sooner. Yeah, so you have a good start.
Yeah,
with the moisture. Yeah.
The other place we find that is where people are double cropping soybeans after wheat. You're really going into a desert situation because that wheat really dries the ground down. And unless Jeff really got us some really good rain after the 4th of July when the wheat's died off, you're coming into a dry situation. Dr. DeFonso, did you see the question? Is there a way to tell if 2 spotted spider mite eggs are visible? After doing a miticide spray, adults and nymphs are clearly dead, but it's hard to tell if the eggs have also been killed.
So I would read the label. The label will clearly tell you if the product will kill mite eggs or not. Most do not. So like a bifenthrin or lorsban type product will kill adults, but will not kill eggs. But some of the specific miticides, like atoxazole, which is zeal, and it'll say it right on the label. And in fact, some of those products kill eggs and young ones, but not adults. Another one that kills eggs is onager. It has like a mule or something like that on the little label. So you have to read the label very carefully. I have a mite cheat sheet that's posted online, and all that stuff is in the little cheat sheet. Because, I read all those labels, and there's some very mysterious things on there. A lot of times, if you're spraying for mites this early, you're digging yourself into a hole because they reproduce very quickly. And once you remove predators, which you would with most of the insecticide products, like a bifenthrin, and then those products those populations can really resurge.
Chris, do you have the website for that you could put into the chat for us, please?
Let me look for it right now.
Thank you.
So there's a question here from our irrigation man, Eric Anderson, who's in that first year of that irrigation position. Given that the current soil moisture and that there's an 8 to 14 day forecast of low moisture potential, do we have enough moisture for double cropping soybeans this year? Younsuk's thinking about that just by the expression on his face. For us, double cropping soybeans in irrigated ground is a very different gamble than dry land. If you're irrigating, you're going to seed the soybeans and water them in, and then water them up and carry them through using the irrigation system. I guess the question is for Jeff, what's the chances of getting 3 or 3.5 inches of water in that 2-week period to replenish what the wheat used?
And Lynn and I agree completely. I think you nailed it. What happens is that, and you mentioned this, and it's so true. We have previous research here in Michigan, though, that the success of that double crop is really, really dependent upon later precip, because the first crop, the wheat crop or whatever, if it's a cover, takes a great deal of what's typically in the profile ahead of the season, and leaves that second crop with a drier subsoil than would be the case otherwise. And of course, as it gets into later stages, it needs the water and it may not be there. So I think that what this translates directly to right now in irrigated, well, first unirrigated, not a rain-fed one, you have decreased the odds of success that second crop without question, as we go in now with a little bit drier than normal, especially subsoils. And Mother Nature may indeed provide this. I would say that the outlook here at least for the next couple months, there basically is no direction on the precip totals, but it is for above normal temperatures. That's been consistent. That's been strong. So one would have to assume above normal PET and evaporative demands into the summer. And so the odds of seeing enough, that 3.5 inches that we need later on in the season, are lower, and having enough water are lower than they would be in a normal or typical year, and in many. And that's just statistically, we're already behind the 8 ball. I guess that's my point. For irrigated, very interesting, very different story. And this is a year where the irrigation, if you've got the double crop, could really pay off. Especially if we do have drier than normal conditions moving into the middle and latter part of the summer. But for the rain fed, it's not that it's going to fail, but it's just that you have reduced the odds of success because of the weather we've had over the last 4 to 8 weeks. I don't know if that makes any sense, but
Dr. Dong, do you have any thoughts on that issue?
No, I think Jeff and you addressed really well. So, yeah.
So we're running out of time. Is there any closing statements from any of our MSU specialists? Well, I want to thank all the speakers that have been here today. I appreciate this opportunity. I want to thank Phil Cates. He's put together a very good format for people like me that are not too computer literate to get through it. I appreciate the audience that's there. Please come back to use the other resources. If you have any questions, type those in, or if you come back to the recordings, you can see our email addresses. Please send us any questions you have, and we'll try to work through those. Otherwise, have a good morning.